In this video, I wanted to look at a couple of examples from our worksheet number 2 that you guys turned in on chapter 4. We didn't have an opportunity to go over some of the problems in class, and so I wanted to take this opportunity to do so. For the most part, item number 1 was good with everyone, so I'm actually going to start with problem 2. It says, at a sobriety checkpoint conducted by the Lexington County Sheriff's Department, 328 drivers were screened and 4 were found to be intoxicated and thus were arrested, right? So out of the 328, 4 were arrested. It says, part A, let I represent the event of screening a driver and getting someone who is intoxicated. So I represents at that checkpoint getting someone who was intoxicated. And so what I want to do is find, this should be a period here, find someone who was intoxicated. Probability of finding someone who was intoxicated, right? And so since there were 4 people out of the 328 that were intoxicated, that's my probability there. And I can leave it as a fraction, or I can change it to a decimal and I'll round it to 3 decimal places, 0.012. Okay. Part B, what does P of I represent? And notice here that this I has a little bar over it. There's a bar there, right? And remember in our notation here, I with a bar over it means it's the complement. And complements are the sort of like the opposite or the inverse or opposite of what I represents, right? And so if P of I represents the probability of finding someone who was intoxicated, then P of I bar is the probability of screening a driver and finding one who is not intoxicated. All right, and so that not there means opposite of this I here, right? And part C, what is the value of P of I complement? Well, there's a relationship between the complement and the actual event. Probability of a complement equals 1 minus the probability of the event, right? And so since we already know that the probability of the event was 0.012, as we found in the first part, this would be 0.988. All right, let's go on to number 4. Problem 3 was pretty good with most people, and so I'm going to skip that one and go to item 4. According to FBI data, 12.4% of burglaries are cleared with arrest. A new detective is assigned to 5 different burglaries. What is the probability that at least one of them is cleared with an arrest, right? Remember, at least one means either 1, 2, 3, 4, or all 5 of these burglaries are cleared with an arrest, right? And we know the probability of a burglar being cleared with an arrest is 12.4%, right? And so when we did these, we paid close attention to when we had at least there, right? So if I let event A represent at least one burglary is cleared with an arrest, I'm going to use my complement of that in order to help me figure out what that is, right? So if I have A as at least 1, then A complement means that no burglaries are cleared with an arrest. And so my goal is to find probability A of A, but remember we have that relationship between A and A complement is that probability of A is 1 minus the probability of A complement, or we can say probability of A complement is 1 minus the probability of A, right? And so my goal is to use this. Now I'm going to use this is much easier to find compared to at least 1 because I have all of these things here, right? I have all of those options. And so I'm going to go with the finding the probability of A complement, and once I find that, I'll have what I need to find my probability of A. Well, probability of A complement is there are no burglaries when I have out of the total of 5, right? There's 5 different burglaries that he's going to have. All right, these burglaries are independent, and so if I want to know the probability of getting no burglary, I'll just do 1 minus the probability that the burglary will be cleared with an arrest, which is 0.124, and that is 0.876. And so the probability of not having a burglary cleared with an arrest is 0.876, and there are 5 burglaries, so I will multiply that 0.876 5 times, or raise it to the 5th power, and that will give me what the probability of a complement is. And so if I want to know the probability of at least 1 burglary, which is 1 minus the probability that there are no burglaries in that cleared with an arrest in that 5, then I do 1 minus that 0.876 raised to the 5th, and I get that probability is 0.484. Okay? So I use the fact that there's a relationship between an event and its complement, and since the complement is a lot easier for me to calculate, then what I'm going to do is I'm going to use that, calculate the probability of the complement, subtract it from 1, and then I get the probability that at least 1 burglary is clear with an arrest. All right, let's go to part B. What is the probability that the detective clears all 5 burglaries with an arrest, right? Well, we have 5 burglaries. By the way, this says to round to 7 decimal places, so you can probably go further here. And the same thing here. What is the probability that the detective clears all 5 burglaries with an arrest? Well, I know that the probability that 1 is cleared with an arrest is 12.4%. And so since these burglaries would be independent, I'll get that 0.124, multiply it 5 times, and I get 0.123, 4 zeros, and then a 293. All right, I'm going to upload the rest of the problems for this worksheet on the next video.